The final situation we want to look at here is a wheel with an axle. The axle has a radius r. It's a little small, you might not be able to read it. And we have a mass tied by a string that's wrapped around the axle. And that mass is going to descend a distance delta y in a time delta t, descending from rest. We're going to assume that there's very low friction here and no friction, or maybe there is some friction. It doesn't really matter. But the one thing that we will assume is that the descent is with a uniform acceleration, starting from rest. So we ask, what's the final angular velocity of the wheel? Okay, that's the question. Now we can't answer that immediately. What we can answer immediately is what the final velocity of this mass is. And from that and the radius of the axle, we'll be able to get the angular velocity of the wheel. We know that the mass starts from rest. We have an initial velocity, we have a displacement, and we have a delta t. Okay, so we find the final velocity of the mass from these known quantities. And that's very easy. Now, we assume that we found the final velocity, and we ask, what does that do to the angular velocity of the system? Well, we take a close-up of the axle here. The wheel's out here someplace. We haven't really drawn it. If the mass is moving at velocity vf, then string is coming off of this axle at velocity vf, which means that the outside of the axle, the rim of the axle, has to be moving at velocity vf. If the rim of the axle is moving at velocity vf and the axle has radius r, well then the angular velocity of the axle has to be omega f equals vf over r. This is just a result, again, of the definition of the radian. Vf is your meters per second. One radius of motion out here is 1 radian of angular motion, and you put all that together and you can see exactly why this has to be the case. But even if you just memorize this as a formula, this is the case. So we found the angular velocity of the axle. Since the wheel is presumably attached to the axle, that's going to be the angular velocity of the wheel.